I don't work for Thoughtworks. I did a long time ago. In fact, I left Thoughtworks in 2006. That's 12 years ago. But it's such an amazing organization full of such wonderful people that I've been friends with the company and individuals ever since. And so I'm extremely grateful that Cassie and Johnny invited me to come and speak here today. So as Cassie said, I'm here to give you a second talk in a row about serverless. 2 talks about serverless, only 1 about Kubernetes. I'll let you be the judge. I'm here to give another talk about serverless. I started using serverless systems about 2.5, 3 years ago. And as Cassie said, I wrote an article that Martin was very kind to host on his website about everything that I'd seen at that point around serverless and trying to sort of help define what it is. That article proved to be extremely popular, and so popular, in fact, that I started my own business based upon it with my good friend John Chapin. We are a consulting business based here in New York, specializing in cloud architecture. So today I want to talk about some of the challenges that you may face as you start using serverless, especially part of it called functions as a service, which I'll mention a little bit in a moment. I'm going to use this through the metaphor of the movie The Princess Bride. Those of you that have seen The Princess Bride, I hope you enjoy. Those of you that have never seen the movie The Princess Bride, if there's going to be one thing to take away from this talk, it's to go home and watch The Princess Bride. Now, of course, this wouldn't be a real serverless talk unless I gave you a very, very brief introduction to what serverless is. Vinny just gave you some of this as well, so I can kick through this pretty quickly. So at its most fundamental, serverless is all about the use of 2 groups of vendor services. And we sort of call these 2 things back-end as a service and functions as a service. Now, back-end as a service are things like really old things comparatively, like Amazon S3. Amazon S3 is a serverless back-end as a service. But there's also things like Auth0. Auth0 is a small vendor that provides everything you could possibly need, most things that you could possibly need, around user authentication, user management, passwords, and all that kind of thing, so that you don't have to worry about coding and operating that stuff ever again. Google Firebase is a database product fully hosted by Google. You don't have to run it yourself, that you can access directly from mobile and front-end clients in a totally secure way. 10 years ago, that would have sounded like an absolutely terrible thing to do. It is now okay to expose your databases, some of your databases, to the outside world. So these are some examples of back-end as a service. Functions as a service is the other side of serverless and is where a lot of the popularity of the term has come from, but it is by no means the only part of serverless. Functions as a service has been made especially popular by Amazon's Lambda product, which has been out for a while now. And by far the biggest use of functions as a service right now is Lambda. FAS is all about breaking our applications down into tiny little functions that we give just as simple source code artifacts or basic compiled artifacts to a vendor platform and let that vendor platform figure out all of the scaling and the resource allocation and the resource management on our behalf. And as you just saw from Vinny's talk, you can use that very well in an event-driven scenario. Now, of course, Amazon Lambda is not the only player in this game anymore. There are many, many other people doing this. Microsoft Azure Functions is my favorite other FAS platform at the moment. They do some really interesting things around developer UX and functions as a service. So that was some of the serverless services that exist. A serverless application is one that makes extensive use of these services. It might not be solely using serverless services, but it's one that makes extensive use of these services. Now, Vinny just showed you one example of that. Here's another example. So this is a single-page web app on the left-hand side. So this is a client that you may give out as a consumer web app. We see that this web app is communicating with a number of different backends. It is not just communicating with our customized server app that we're building on the back end. It is also directly communicating with hosted services. So maybe an authentication service, maybe it's getting its product database from something like Google Firebase directly. But of course, we do still want to develop some of our own code as well. And if you're doing that in a serverless way, you're typically going to do that in these functions as a service functions. And you may host them behind an API gateway, which allows you to use Lambda functions as an HTTP-backed service. Now, the other point I want to make here is that that top function, that purchase function, is communicating with a database. And that database might be a traditional SQL database. The point here being, you do not have to have a 100% serverless application. You can mix and match technologies as makes most appropriate. I'll talk about some concerns about that later in the talk, but know that you don't have to be a 100% serverless app to get the serverless seal of approval. Okay, all fun and games and yet more architecture. Didn't we just have Kubernetes come around and solve all our issues for the next 5 years? Why do we want to have something else? Well, it really comes down at a very, very high level to two things. First of all, just like the cloud in general, this is all about reducing costs from one extent. So first of all, labor costs. There's less work to do in our own companies. And also infrastructure costs. So we're actually typically, you find with many serverless applications that you're going to pay less for your infrastructure than you would with a more traditionally deployed application. And this all comes down to the economy of scale that vendors can work in. So they can give you back some of that economy of scale through lower costs. So that's one thing, and that's sort of the ticker, the headline item for serverless is reduce costs. It's not why I'm excited about it. Why I love serverless so much is about this idea, concept to production in hours. I have never worked with any kind of platform where a group of people can have an idea for something new that they want to develop and have that in production running at scale in a matter of hours. And this is not hyperbole, I've seen this done. And this idea where you don't have to have this whole large massive application ecosystem and try to find out where you can bolt on your idea. The fact that you can deploy a completely greenfield app at scale to production is something I think that is a particularly powerful motivation for serverless. Now, there's a lot more I could talk about serverless, which I'm not going to today, around benefits and concerns. If you want to know more, I recommend my article, or also you can find a lot of stuff on my website. But let's get on to the meat of this. There are a lot of challenges to serverless. Some of this stuff, especially around functions as a service, is very new, and it's also quite different to how we've built applications in the past. And so it's unsurprising that there are limitations here, and there are challenges around how to use this stuff best. Now, I want to talk about a few of these thornier concerns at a fairly deep technical level. I talk sometimes about the business benefits of serverless. Today, I'm going to work with you on some of the technical stuff. And I'm also going to talk mostly about functions as a service. Backend as a service is sort of an older way of working. Functions as a service is much, much newer. So, the first challenge, the flame spurts of unmatched scaling. One of the wonderful things about Lambda, especially, is that it will auto-scale hugely wide very, very quickly. You can build a function in a few minutes, deploy it to Lambda, and then put it on Hacker News, and suddenly your Lambda function can scale 1,000 wide without you doing any work at all. It's absolutely wonderful, unless you'd accidentally put a SQL database behind all those Lambda functions that's also being communicated with a bunch of other services. At this point, your SQL service might your SQL database might turn into a nice pool of lava on the floor. And it's not just about databases. It's any other kind of microservices that haven't been built with this very, very elastic auto-scaling in mind might be under impact if you are connecting to them from your Lambda functions. So how do we solve for this problem? Well, the obvious answer is to use like scaling infrastructure. So if you're going to communicate with a database from your Lambda function, maybe also use a database that can elastically auto-scale in the same way that Lambda can. So a great example here is using something like DynamoDB in Amazon, and DynamoDB now has auto-scaling. And so if you use DynamoDB with Lambda, you have this like scaling infrastructure, and you're all happy. Okay, that's great. That's the land of sunshine and unicorns. What if you're in real world and Dynamo doesn't work for you? Well, one thing here, and this is a very, very, very small thing that can have a massive impact on how you design your architecture. Amazon introduced a new configuration option to Lambda deep in the bowels of reInvent. It might not even have been in reInvent. It might have been a side talk last year in November, where you can actually limit the concurrency of Lambda now. Instead of it scaling unlimited to 1,000 or more wide, you can say, actually, no, only scale this Lambda function 5 wide or 10 wide. It's completely up to you. And this is a thing called Lambda reserved concurrency. And so this is sort of a sledgehammer approach, but this might be, in a lot of ways, might be something that you can do to get started. The best approach, in my opinion, is to build a deliberately hybrid architecture. That is one where you are using the right component in the right place, and where they do have different scaling properties, then introducing other components in between that will flatten out or flatten out your throughput. So a good example here is maybe you want to introduce a message bus between your Lambdas and your protected SQL database. And it's really important that you understand the capabilities of all the different components available to you and build a deliberately hybrid approach for that. Okay, let's move on to the lightning sand of at least once execution. A very popular use of Amazon Lambda is for scheduled tasks. So most of you have probably worked in an organization where somewhere there is the one cron server to rule them all. 70 different cron jobs, all installed on one machine. No one owns all of them. No one really knows what the environment is on there, and you daren't touch it lest it falls over and the whole company falls apart. The lovely thing about scheduled Lambdas is that you can build a Lambda function, deploy it to Lambda, you give it a schedule that is a cron formatted schedule, and it's a completely isolated environment for every single Lambda instance. And that's a really, really powerful benefit over the one cron server to rule them all. There's one problem with this. Lambda guarantees that when an event occurs, your function will be executed at least once. It may be executed more than once. This happens rarely, but this is a distributed system. And so you occasionally get a Lambda function being called more than once for the same event. And that's not just for scheduled tasks, that's for any event source in the Amazon ecosystem. I'm just using cron here or scheduled here as an example. So, how do you deal with the fact that your functions may be called more than once for the same event? The most important thing to be thinking about here is about idempotency. Now, this is nothing specific to serverless. As people start using microservice systems at scale, the ideas of idempotency become more and more important. And briefly, the idea of an idempotent system is one where if you process the same input more than once, it only has the effect that if it had processed the input once at all. There's a lot more to it than that, but that's basically it. Now, if you're building a purely stateless Lambda function, great, it's idempotent, well done. If your Lambda function is dealing with a bunch of downstream services that themselves are idempotent, congratulations, you've got an idempotent system. And that's wonderful. So if you can build a system like that, where everything is idempotent and thinking about this stuff, then you can build at scale and there's no concerns. Okay, that again is the land of rainbows and unicorns. Less so, that actually does happen quite a lot. It's rare that people have to worry about this, but sometimes they do. If you do have to be concerned about what this means, you need to check for previous processing. Have I processed this event before? Now, one nice thing that Lambda does is even though it may call your Lambda function twice for the same event, it guarantees that the request ID, which is a little bit of metadata that comes through with the event, is the same for every single instance of that execution. And so you can use that basically to form some kind of transaction. A really easy way of doing that is to use a feature of DynamoDB called conditional writes. So if you combine that unique request ID with DynamoDB conditional writes, you can basically check to see whether that event has been processed before successfully. And if it has, you can just throw away the next execution of that event. Easy. You can solve all these. It's not a problem. All right, the next one. The ROUSs of the Serverless Fireswamp are not rodents of unusual size. Instead, they are regions of unusual stability. For those of you that aren't used to Amazon, Amazon collects all of its data centers into little clusters called regions. There are at least 4 regions that you can use in the US. If you work for the government, there's more than that. But basically, there's 4 regions in the US and many more across the world. Occasionally, these regions can be unstable, especially US East 1, which is where most of the tech companies in the US work. US East 1 happens to be the most unstable AWS region there is. The reason that everyone uses it is because it has the most capacity. There's this sort of network effect there. But occasionally a region can go down. And when it does, there's not much we can do about that. We don't know when it's going to come back. We don't know exactly what the impacts are. So yeah, what do we do about that? The key thing to be thinking about here is multi-region. So all of these regions that Amazon have are operated completely independently. There is very, very, very little interaction between the regions from a management point of view. And so if one region goes down, it's extremely unlikely that another region is going to go down at the same time. That basically just hasn't happened on a major scale at all. And so it's a good idea here to be thinking about hot standbys between these regions. Netflix have been talking about doing this for years. Netflix operate in 3 regions at any one time, and if one region becomes unstable, they just route the traffic to the 2 other regions. It's a lot easier to do that in serverless, and it's also a lot cheaper because you're only paying for execution in serverless when your code is actually doing something. So you can deploy your code to 15 other regions. If it's just sitting there doing nothing, you don't have to pay for it, which is a major benefit over other ways of working. Another idea here is to not use regions at all, but is to embrace the idea of edge computing, which might be IoT devices, but if you're not quite as hip as that, using something like Amazon's Lambda at Edge functionality. Lambda at Edge allows you to deploy Lambda functions to Amazon's CloudFront network, which has more than 100 data centers across the world, all independent. And so if one of those things goes down, you have another 100 or so ready to go. And you only deploy your Lambda function once, and it just gets automatically distributed across the CDN. The first time you do this, and you don't know which continent your code is working on, it is a very strange experience. In this way, we're starting to think about moving beyond serverless and to regionless computing. This is still quite a new area, but it might help you out. Whatever you pick, make sure to embrace chaos engineering as a way of testing this. Regions don't go down very often, and so it's important to test. And chaos engineering is a great way to test here. Okay, so we've been talking about some nice problems that we're having in the warm, hot Fireswamp. Just when you're enjoying the warmth, I'm going to talk about the last problem, which is cold starts. Cold starts, to many people, are the bogeyman in the Lambda room. Cold starts are all about when your code needs to be running for the first time for a new version or it scales out. You'll see a delay in that execution. That might be anywhere from a couple of 100 milliseconds up to several seconds. And because of that, and because you can't control when that starts and stops, people get very, very worried about it. Turns out it's not nearly as big a problem as you may think. So the first thing to think about with cold starts is to measure first. Actually analyze what is going on in your system, figure out what your performance requirements are. You might not have a problem with cold starts at all once you start using it. And that turns out being the case 9 times out of 10, I would say, that sort of order. Maybe even more than 9 times out of 10. At that point, you can just stop worrying and move on. If you do need to be thinking about cold starts, there's a few things you can do. And I'm only going to talk about 2 here. I have a long article about other stuff you can do here, but I just want to mention a couple. First of all, make smaller code artifacts. We're used to building 100 megabyte, 200 megabyte zip files of our code and libraries and just dumping it on a server somewhere with all the other ways that we've been building software. This is not a good idea for Lambda. In fact, you can't deploy an artifact that's bigger than 50 megabytes. So when you're thinking about building your Lambda function artifacts, think small. Have just the dependencies you need, just the code that you need. The smaller your dependency, the smaller your artifact, the quicker your cold start time is going to be. I'm a huge fan of using Java on Lambda. That's a very uncool thing to say, but I've been using Java on Lambda for years. Sometimes it's not the best option. It's no doubt that cold starts with Java are a little slower than they are for other languages. And so if you really are tight on your cold start time, then you should be considering using other languages like JavaScript, Python, or Go. But only use that as a reason if you really have a problem with cold starts that you can't solve another way. Okay, so those are some tactical things that you can get around. I just want to close out with some few bigger questions about serverless that I want to mention. First of all, throw out your old ideas of architectural constraints. Serverless economically is basically just a progression of the cloud all over again. Serverless architecturally is not. It's very, very different. How we build systems, effective systems in a serverless way, is very different to how we built systems in the past. There are a number of documents coming out on this, but I definitely recommend that you look up about people that are building effective systems. There's a link for this talk with some resources on it. There's a talk on there from Gojko Adic that he gave last year at a GoTo conference, and it's very, very good and talks exactly about this kind of area. Next, the point about serverless is doing less work, both building less code and operating less code. If you find that you are either writing something or running something that really isn't germane to what you're doing, see if somebody else is doing that for you and get them to do it on your behalf. Be lazy. And finally, the cost constraints of using serverless technology no longer apply. It is extremely cheap to dip your toe in the water and try out 5 different Amazon services, see how they all interact together, and then tear it down at the same day or the next day. You might end up not paying anything if you do that within Amazon's free tier. And so the cost for experimentation is significantly lower than it's been before. And our creativity is really able to flourish with a serverless approach in a much bigger way than it's been able to before. So I really encourage you to experiment with this stuff, learn what it does, and then share that with your teams and with your organizations. And of course, the most important thing is that everyone lives happily ever after. Thank you, everybody.